This video is our first in our factoring chapter, and I'm going to actually split this guided notes section into two videos: how to factor using the greatest common factor, and then how to factor by grouping. So I'm going to do two separate videos. So let's talk a minute first about what factoring actually means. And I think the best way to show you is to compare it to its opposite, which is multiplying. So let's drop down to a very low level, third grade. If you're multiplying, you would be given a problem, 3 times 2, and then you would write the answer as 6, and 6 is your answer. The factoring version of that would be, here's the answer, 6. What did the problem look like? In other words, what were the factors? And you could say, well, 6 times 1 or 3 times 2. That's factoring. It's starting with the answer and then working backwards. It's like Jeopardy. Here's the answer. What was the question? Let's move up to an algebra example. I hope you recognize this as the distributive property, and you would be given this and asked to distribute, and you would get 4x plus 8. The factoring version of that is, here's 4x plus 8. What did it look like before it was distributed? Well, there was a 4 on the outside, and there was an x plus 2 in parentheses beside it. So that's working backwards. And we're actually going to do, this is the one we're going to do today in this video. Finally, as another example of multiplication versus factoring, I hope you recognize this as a very straightforward FOIL. And what you would do is first, outside, inside, last, and then combine like terms, and you would get x squared plus 5x plus 6 as your answer. In factoring, I will give you x squared plus 5x plus 6, and I will say, what did it look like before it was FOILed out? And you're going to learn to say, oh, that was x plus 2 times x plus 3. And I'm going to teach you how to do that too in another video. So that's what factoring really is. It's the undoing of multiplication. So before we can look at our first factor type, which is factoring out the greatest common factor, let's do a real quick review on what is a greatest common factor. So in example 1, it says find the GCF. Here I have two numbers. Now you may or may not recognize what the greatest common factor of 28 and 40 is, but if you don't, and let's assume you don't, there is a simple way to do it. I can do a factor tree for each of my two factors. This I'm going to write as 4 times 10. So 2 times 2 times 2 times 5. And then my greatest common factor is what they have in common. So let me use a different color here so you can see. So do they both have a first 2? Yes, they do. Do they both have a second 2? Yes, they do. So they have that in common. Do they both have a 7? No, they don't. That number's done. Do they both have a third 2? No, they don't. And they don't both have a 5. So my greatest common factor, the parts they had in common, was just 2 times 2, or 4. Now it's actually easier to find the greatest common factor with a list of variable terms. So here I have x cubed, x to the 7th, and x to the 5th. The greatest common factor is the most that they have in common. The most they have in common is x cubed, because this one doesn't have enough to have more in common. Here, the most they have in common is just a y, because this one doesn't have enough to have more. So in general, when you're finding the greatest common factor of a list of variable terms, it will always be the variable with the smallest exponent, because that is the most that they have in common. That small one doesn't have enough to have more in common. So let's combine numbers and variables. So finding the GCF of each of these terms, we have a negative 18, a negative 63, and a 27. Don't let the negatives throw you. That doesn't change anything. The biggest number that goes into those is 9. Then we have y squared, y cubed, and y to the 4th. The most those y's have in common is 9y squared. So that's the GCF of that list of terms. It's the biggest number that would, or biggest term that divides into each of those. Here we're going to do the a's and the b's separately. So I have a cubed, a to the 5th, and a to the 6th. The biggest a that goes in is a cubed because this one doesn't have enough for it to be more. Then I have b squared, b, and b squared. B is the most they have in common. So that's finding the GCF. And we'll use that in just a minute. So let's talk about this chart. This is a chart I'm going to continue to add to as we go through this video. So the first factoring type that we are going to learn is factor out the GCF. Now, one of the hardest things about factoring is recognizing when it is appropriate to use which type. So one of the ways to help you recognize that is how many terms you see. Unfortunately, factoring out the GCF is probably the hardest one to recognize because you can have 2 or more terms. So that doesn't really help that much. When you're finished factoring, though, your answer will look like a distributive property problem. So before I add to this chart, I'm going to put this aside and let's look at how you factor out the GCF, or factoring out the greatest common factor. So here I have a binomial, 5ab plus 10a, and I want to factor it by factoring out the GCF. So what you do is you say, first, let's identify the greatest common factor for the two terms. 5 is what goes into the number parts. What else do they have in common? They both have an a. They do not both have a b. But rather than stopping with just identifying the GCF, we're now going to put parentheses because remember, we want it to look like the distributive property when we're done. And we're going to divide. This 5 would cross cancel that 5. This a would cross cancel that a, and what would be left? A b. Put your plus, divide again. This 5 goes into 10 2 times. This a would cross cancel that a, close your parentheses, and I have my factored form. That is the answer we are trying to get to, is what did this look like before it was distributed. Now what's nice about factoring is that it's very easy to check it. I can check it by distributing. 5a distributed to b would be 5ab, and 5a times positive 2 is 10a, and what I get is what I started with. So I know that my answer, the factored form, actually works. Let's try another one. What is the GCF of y to the 5th and y to the 12th? It's the most they have in common. It is y to the 5th. Now when we divide, you have to be careful here. Y to the 5th goes into y to the 5th. They would cross cancel, making what? A 1. And it's critical that you show that 1. I'll show you why in a minute. Minus y to the 5th would cross cancel 5 of those, leaving y to the 7th. This is my answer, but I'm going to check it with the distributive property in green here. So y to the 5th times 1 would be y to the 5th. That's why you got to have the 1 there. And then minus y to the 5th times y to the 7th, product rule. I add my exponents and I get y to the 12th, and it checks because it matches what I started with. Let's do another one, and this is more typical of what your directions would say. They won't say factor by factoring out the GCF. You're supposed to recognize it. It's just going to say factor. So what goes into 6 and 12? 6. How about A4 and A? Just A, parentheses. Now do your division. 6 cross cancels 6, and this A cross cancels one of those, leaving A cubed. 6 goes into 12 2 times. The A's cross cancel, and I have my answer. We're going to continue to check these with the distributive property because you can. So distribute 6a times a3 would be 6a to the 4th. 6a times -2, -12a, and it checks because it matches. All right, remember on our chart, let me bring it back a second, we said you can have 2 or more terms. Well, this one is an example of one that has 3 terms. So I have to look at the GCF of all 3 terms. Let's start with the numbers. What goes into 15, 20, and 5? 5. P squared, P cubed, and P cubed. The GCF is P squared. How about Q to the 4th, Q to the 5th, and Q cubed? Q cubed. Now put your parentheses. We're going to go nice and slow, one step at a time. 5 goes into 15 3 times. P squared would cross cancel P squared. Q cubed would cross cancel 3 of those, leaving a Q. 5 goes into 20 4 times. P squared cross cancels 2 of those, leaving a P. Q cubed cross cancel, oh wait, this is a Q to the 5th. I couldn't see, I thought it was Q cubed. Q cubed cross cancels 3 of those, leaving Q squared. 5 goes into 5 one time. I'm going to write the 1 because I need it as a placeholder in case the other letters all cross cancel. P squared goes into P cubed. There is a P left, so I really didn't need that 1, but it's always safe to put it. Q cubed cross cancels Q cubed. And I have my answer. Let's check it in green by distributing back. So 5 times 3, 15, P squared, and Q cubed times Q is Q to the 4th. So the first term checks. Distribute 5 times 4. P squared P makes P cubed. Q cubed Q squared makes Q to the 5th. The second term checks. 5 times 1 is 5. P squared P makes P cubed. Q cubed times nothing is Q cubed. And the third term checks. So it checks because when I distribute back, I get what I started. The next section is on factor by grouping, and that is on a separate video.